Hi, today we are continuing with momentum, dealing with collisions in 2 dimensions. Now, lots of principles for this would just be the same as in 1 dimension, except for we're having to add an extra dimension, which means trig. So 2D collisions will solve these the same way as we would with linear collisions, except for we'll do conservation of momentum in each axis. So we'll do it in a north-south direction and an east-west direction. So we'll do an example of this. So we have a 1,325 kilogram car traveling east at 17 meters per second, collides with a 2,165 kilogram car moving north at 27 meters per second. If they stick together, what is their final velocity? So once again, I'm drawing out what's happening before and what's happening after. So before, we can see that we have object A traveling at 17 meters per second with a mass of 1,325 kilograms, while object B is traveling north at 27 meters per second with a mass of 2,165 kilograms. Afterwards, they're stuck together, traveling at an unknown angle at an unknown rate. So we can either start with north-south components or east-west components. Either way, we get the same answer in the end. So I have chosen to start with east-west components. So before the collision, we had 2 objects. So our initial momentum would be momentum of A plus momentum of B, which we can break into the mass times velocity for each of them. Now, our object A was moving east-west, so we can put its velocity in there, but object B was moving in the north-south direction, so its initial east-west component would be 0. Now calculating this gives us initial momentum of 22,525 kilogram meters per second, and that'll be our final momentum in the east-west direction. Now afterwards, our objects are stuck together, so our momentum final is just equal to a momentum of those 2 stuck together. So we can replace that with mass times velocity, divide both sides by the mass, substitute values in, knowing that our mass is the addition of our 2 masses, and we know that we have an eastward component of velocity of 6.45 meters per second. Next, we'll look at north-south components. So once again, break into before and after. So before, once again, we've got 2 separate objects. So we've got momentum of A initial and momentum of B initial, putting in our mass times velocity for each of those. But in this case, the first object, object A, was moving eastward. It had no north-south component, so its initial velocity will be 0. While our object B, we can use the velocity we were given at the start. So substituting our values in, we get an initial north-south momentum of positive 58,455 kilogram meters per second. And then once again, afterwards, the objects are stuck together, so our momentum is equal to the combined momentum of them. We can substitute in mass times velocity for momentum, rearrange it, and we get momentum over mass. The combined mass gives us our velocity. Substitute our values in, and we get 16.75 meters per second in the northern direction. So we have a northern component and eastern component, so now we need to use trig and combine those. So we have our eastward component as well as our northward component. They're at 90 degrees to each other. We have a resultant here. We can use Pythagoras to get the magnitude of that resultant. and we get that it's traveling at 17.9 meters per second. And then I'll use trig to get our direction. So our angle is equal to arctan of 16.75 divided by 6.45, giving us an angle of 69 degrees. So we can say our overall answer is 17.9 meters per second at 69 degrees north of east.